Okay, everyone. So here's the situation I want you to think about. You're taking the ACT or SAT exam, or you're in college, you're taking a test in a higher level math class. And at some point, you need to know the value of sine of 5 pi over 6. But no notes are allowed. Not allowed on the ACT, SAT, or a rule your instructor has at college. You're not allowed to have notes. If only you had your unit circle. Well, memorizing the unit circle is awful. If you had it memorized, you could grab a piece of scrap paper, write it out really quick, and then use it on your test. But man, students for years have been doing that or trying to do that with different degrees of success. But it's basically a painful thing to have to do, to memorize that entire thing. A better alternative is reconstructing. And it's surprisingly easy to do. And I'm going to give you a little trick called the left hand method. If you Google left hand method, unit circle, search YouTube, you're going to find lots of videos on this. Some are long and more drawn out than they have to be. I'm going to keep it as short and simple as I possibly can. So here's a unit circle, and there's a left hand. Okay, so here's the deal. Ideally, you're going to reconstruct the entire unit circle. Remember, the unit circle has 1, 2, let's see, you can't see that. Let me get a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 different angles in it, each one with its own endpoint, plus the various radian versions as well. Oops, didn't mean to do that. I only want to erase, how many marks did I draw in there? Anyway, you can just focus on the first quadrant because there's so much symmetry. If you get the first quadrant done, you can use symmetry to get the numbers in the next quadrant and then the other numbers down here. Because they all are the same numbers repeated over and over, they're really easy to figure out. The angles, likewise, you can reason through that. I keep erasing stuff I don't want to erase. Did it again. Okay, you're going to have to forgive me here. I wanted to keep this video short, and every time I make a mistake, it adds time. So let's do this. So we're just going to focus on the first quadrant, how you do this, how you use this left-hand rule to do it. Okay? So each fingertip is a square root, right? And the three middle fingers between the pinky and the thumb, those are your 30 degree, 45 degree, and 60 degree angles. Now keep in mind, how does this work? You got x and y, which is sine and cosine. Okay, so here's what you do. If you want to know any one of those points in the first quadrant of the unit circle, put that finger down. Now, how am I going to illustrate putting a finger down? I think I'm going to shade it out. So this finger is put down. Okay. We're going to find the left value first. The x value is on the left, the y value is on the right. You know what I mean? So, how many square roots are to the left of the finger that's put down? There are 2 of them. So our numerator is going to be square root of 2 because there's 2 of them. The denominator is over 2. The denominator on every point is going to be over 2. Now, you might not think that is the way the unit circle works, but it is. Bear with me. Every denominator is over 2. You don't have to memorize a bunch of different rules. It's just the way it is. Every point, every denominator is over 2. So for the x value, that's the left hand value, we look to the left of that finger. There's 2 square roots, so we call that square root of 2 over 2. For the right hand value, the y value, we look to the right of that. And again, there are 2 square roots, so we call that square root of 2. So that point is now made. Square root of 2 over 2, square root of 2 over 2. Okay, let's do a different angle. Let's do the 30 degree angle. So we're going to black that out. The x value, which is on the left side of the comma, we look to the left of the blacked out finger. How many square roots are there? There's 1, 2, 3. So that's square root of 3. How many are to the right? Because this is going to give us our y value, or the right hand value. Well, on the right, there's 1 square root. But what is the square root of 1? The square root of 1 is just 1. You can simplify that. And now you got that point. Square root of 3 over 2, comma, 1/2. Let's look at 60 degrees. Oops. Put the 60-degree finger down. How many points are to the left? Or, sorry, how many fingers are to the left? 1. So that's square root of 1. But wait, square root of 1 is just 1. Look to the right. How many square roots are there? 1, 2, 3. Square root of 3. Now that point is 1/2 square root of 3. What about these other points? How are they halves? Well, first of all, you might not need to process these other points this way. You might already know that this is over 1 up 0. So there you go, 1, 0. But let's just say you want to use this left-hand rule, which says everything is over 2. Okay, let me erase these little marks here. And so we're going to black out the finger that we're doing right here. Okay, the left hand, or the x value is on the left, so how many square roots are to the left of this finger? 1, 2, 3, 4. So that's square root of 4. But what is the square root of 4? Square root of 4 is 2. And 2 over 2? 2 over 2 is 1. So that makes this a 1. Now let's look to the right. How many fingers are to the right of that blacked out finger? 0. There are none. What's 0 divided by 2? 0 over 2 is 0. So it does indeed give you the right numbers. Similarly, if we come up to this point up here and we black out the thumb, how many points are to the left? How many fingers are to the left? 0. 0 over 2 is 0. How many square roots, how many fingers are to the right? 1, 2, 3, 4. Square root of 4. Square root of 4, of course, is 2. And 2 divided by 2 is 1. So if you remember, the fingertips of your hand are square roots, and every point is over 2, then you've got the unit circle, and you didn't have to memorize hardly anything. You just have to memorize how it works. And if you look at that and say, well, that only gives me the first quadrant. Again, the second quadrant, you just, oops, didn't mean to do that. Let me sketch in your 3 lines. I'm being hasty here, but you know. Remember, this quadrant is, the x's are all negative, the y's are all positive. Copy these numbers over here. Copy those numbers over here. Copy those numbers over here. This point, of course, is -1, 0. You can similarly do this quadrant. Just keep in mind every point is negative, or every coordinate value is negative. But just copy the numbers from up above. Square root of 3 over 2, 1/2. Square root of 2 over 2. Square root of 2 over 2. 1/2 square root of 3 over 2. To finish this quadrant off, this time only the y's are negative. And copy the points from up above. Square root of 3 over 2, 1/2. I'm being sloppy and hasty because I don't want this video to drag on forever, so forgive me. And then copy that last one, 1/2 negative square root of 3 over 2. What's this point? It's over 0, down 1. Now the whole unit circle is done except for the angles. The angles, honestly, I don't have this great simple little trick to help you, reconstruct those. You're going to have to kind of figure those out. If you can count by 30s, that helps. So 30, 60, 90, 120, 30 more. Now I'm skipping the 45-degree angle. That's a whole other thing. 150, 180, 210, 240, 270, plus 30 is 300. Sorry, I almost wrote 270 again. 300, 330. What might be the hardest one is the 45s. Counting by 45 isn't quite as easy as counting by 30. But what do you got? You got 45. 45 and 45 is 90, but that's already written in there, so that's not a thing. 90 plus 45 is 135. 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. That's already written in there. 270 plus 45 is 310, 315. So you're going to have to do a little work here, maybe. Maybe you have an easier way to process that and think it through. And then for the radians, well, again, there are tricks you can do that might be helpful. Like if you just learned that 30 degrees is the same thing as pi over 6, and 60 degrees is pi over 3. Something about that sticks in my brain. The fact that there's a 6 and a 3 here and a 3 and a 6 there, and they're kind of opposites, kind of works for me. I don't know. 45 is pi over 4. And that sticks in my brain. I don't know why. Maybe because there's a 4 there and a 4 there. But otherwise, you might just want to do the conversions where you multiply by pi over 180 if you want to fill the whole rest of the thing in. Oh, I forgot, this is 0 degrees, which is the same thing as 360 degrees. 0 radians or 2 pi radians is a full circle. Oh, so 180 degrees is pi, and 90 is pi over 2. That's half of pi. 270 is 3 pi over 2. So maybe you can memorize some of the radians. Maybe you can't. You might need to calculate those. But this whole left-hand rule, the idea is it quickly allows you to reconstruct the first quadrant. Once you have the first quadrant, well, half the time when you do math trig, it's in the first quadrant anyway. But if you need the whole unit circle, you can just kind of reconstruct and reason through instead of having to memorize all of those numbers, which is a real painful thing. So there it is, a quick rundown on the left-hand method for not memorizing but reconstructing the unit circle. Ideally, if you ever need it, you've got it for notes and it's not against the rules, but if you find yourself needing the unit circle for the SAT, ACT, college math class with a no-note policy, it's something you can reflect on and use. And if a year from now you don't remember this lesson, you just know it exists, you can Google, trig left hand or unit circle left hand. It'll pop up and then you can review it and have it at your disposal. All right, gonna stop there. Have a good weekend. This is the last thing for the week, and I'll talk to you later.